You know, when you think about a star being born, you probably imagine this massive cosmic bang, right? But what if one of its very first acts is something a little more, well, familiar, something like a sneeze? All right, so take a look at this. It's an incredible illustration of a baby star, a protostar, doing something really weird. It looks like it's just blasting out these huge streams of gas, dust, and energy. And astronomers, they've got a great nickname for it. They're calling it a cosmic sneeze. Which, of course, brings up a pretty obvious question. How on earth can a star, this giant ball of gas, actually sneeze? Well, that's exactly what we're going to get into. This mystery takes us right into the heart of a chaotic stellar nursery. So, to find our sneezing star, we've got to travel about 450 light years away to a place called the Taurus Molecular Cloud. It's basically this huge, dense cloud of gas and dust. And tucked away inside a little region called MC27, scientists have found our main character, a tiny baby star, just starting out. And when I say baby, I mean it. This isn't just a young star. It's a stellar infant. It's barely 200 years old. That makes it one of the youngest protostars we've ever seen. And because it's so young, it's giving scientists this incredibly rare chance to see what a star looks like almost at the exact moment of its birth. Okay, to really get how wild this is, let's put it in perspective. Usually when an astronomer talks about a newborn star, they're talking about something that's already 100,000 years old. And our own sun, it's about 4.6 billion years old. So seeing a 200-year-old protostar, that's like being able to watch the first few seconds of a person's life. It is an absolutely unique window into the very, very beginning of a star. Now, this whole cosmic sneeze thing, it's not just a cool light show. It turns out it might just be the key to solving a huge puzzle that's been bugging astronomers for decades. It's called the magnetic paradox. Okay, but before we get into the paradox itself, you need to know where all this action is happening. It's all going down in something called the protostellar disk. Just picture a giant spinning platter of gas and dust. It's like a cosmic construction site, you know? It's feeding the baby star at its center, and it's also got all the raw materials needed to build planets later on. All right, so here's the problem, the paradox. The giant clouds that stars are born from, they're packed with magnetic fields. So logic says that as that cloud collapses down to form a star, all that magnetic energy, that flux, should get squeezed and concentrated right into the star itself. The result should be stars with magnetic fields that are crazy powerful, like thousands of times stronger than what we actually see. But that's not what we observe in stars like our sun. The numbers just don't add up. So where does all that extra magnetic energy go? That's been the big mystery for so long. Because if a star hangs on to all that magnetic force, it actually struggles to grow. It kind of chokes itself off. So it has to get rid of it somehow. The question is, how? Well, to find some answers, astronomers pointed one of our most powerful eyes on the sky towards the problem, the ALMA observatory down in Chile. ALMA is this incredible radio telescope that can see right through all the thick dust in these stellar nurseries and get a good look at what's happening up close to these baby stars. It's pretty much the perfect detective for a cosmic mystery like this. And they'd already found a clue. In earlier studies of this exact same star, the team spotted these little spike-like things shooting out from the disk. They were definitely interesting, but they were also pretty small, you know? Only about 10 astronomical units long, which is about 10 times the distance from Earth to the sun. But then the team decided to zoom out a bit to take a wider look around the star. And what they found next was, well, it was completely unexpected, and it was on a much, much bigger scale. Get this. They found a massive, warm, gassy ring stretching out 1,000 astronomical units from the star. That is 100 times bigger than those little spikes they first saw. This wasn't just some little puff of smoke. No way. This was a colossal blast of energy. I mean, the discovery was so shocking and so clear that the lead author of the study, Kazuki Tokiyuda, said he was so excited he wrote up the first draft of the paper in just 2 or 3 days. That kind of excitement tells you just how big a deal this was for everyone in the field. Okay, so we've got our clues, right? The little spikes close in, and this giant warm ring further out. So how do we connect the dots? What's the theory that explains this whole sneeze thing? Well, the leading theory is something called interchange instability. And yeah, it sounds a little complicated, but the idea is pretty straightforward. Basically, that spinning disk just gets wound up tighter and tighter with magnetic energy until, bam, it becomes unstable. And that instability triggers a reaction between the magnetic fields and the dense gas, which causes this massive, violent eruption of magnetic energy, gas, and dust all at once. So let's break it down. Step 1, all that magnetic energy from the stellar nursery gets packed into the disk. Step 2, things get unstable. Step 3, you get the sneeze, a super fast, violent ejection of all that pent-up energy. And finally, step 4, the aftermath. That high-speed blast creates shock waves that heat up all the gas around it, and that's what forms the giant warm ring that ALMA spotted. All right, so that explains one star's sneeze. Pretty cool. But why does this one observation matter so much? What does it tell us about how all stars are born, including our very own sun? Honestly, this could be a total game changer. For one, it gives us a real, observable answer to that magnetic flux paradox. This is how stars shed all that extra magnetic energy. It also proves that star birth isn't some smooth, calm process. It's messy, it's chaotic, it's violent. And it suggests that these sneezes might actually be a totally normal, maybe even essential stage in the birth of every star. Yeah, even our sun, way back when. And this didn't happen overnight. As Professor Masahiro Machida pointed out, it took his team a full decade to get to this conclusion. It's a great reminder that science is often a long, slow grind. But the payoff? A discovery like this that shows us the beautiful chaos at the very heart of creation. Just amazing. So, a single sneeze from a baby star has completely shaken up what we thought we knew about star formation. And it really makes you wonder, right? If the birth of just one star is this wild and chaotic, what other incredible secrets about our own cosmic origins are still out there, just hiding in the dust, waiting for us to find them?